All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna continue um, exploring the. I guess we're gonna, dude. I didn't think about this before I hit start streaming. I just knew we were gonna continue doing something Rust related. I have been continuing reading about this generic implementations thing. And it's been pretty interesting learning all of this because, okay, there's these two statements that I was trying to understand yesterday. I don't remember if I understood this first statement on stream or if it was off stream. I believe it was on stream. I understood that this statement basically means that, let's say we've implemented from from U8 to MyStruct O2, just as an example, going back to my code here. Let's say we have MyStruct O2, and okay, here I've done I32. Okay, let's so if we have implemented if we have an implementation of from I32 for MyStruct O2, then there's going to be an implementation of into MyStruct O2 from I32 or for I32. So just like how there's this, impl from I32 for MyStruct O2, there's going to be an implementation like, actually, I can show the implementation right here. Um, yeah, there's going to be this implementation, which basically says it implements into MyStruct O2 for I32. So you can see here it says into U is MyStruct O2, and additionally, one of the bounds is that U implements from I32. T is I32 in this case. So it's kind of like a circular kind of thing going on, like one, they both connect to each other. And the great thing about this is that, like, into it has like a blanket implementation because of this basically. So whenever you have from T for U, you can expect an into U for T. So that's something good to keep in mind. That also makes it so I'm able to do stuff like this, which I never thought about before, like just using a string slice and calling into on it, and then that returns a string, not a string slice. We are calling into on a string, on a string slice, and that returns a string. I looked into this. I don't remember if I have this, if I have the string thing loaded. Give me a second. Okay, yeah. I don't know if I have the string. I don't think I have the string page loaded. So let me search for string, and then there I can show you a from implementation of it. Actually, there was a, oh yeah. So when I had seen from, wait, let me look this up. String, open up string, and here we have, what is this? Methods? No, I'm looking for implementations. Trait implementations. So we have from str, from, well, ampersand str. So knowing this thing, this from this statement. It helps a lot. What am I in right now? I'm in from. Yeah, knowing this statement, it helps a lot because this tells me that if I ever see if I ever see something like this, or actually specifically something like this, if I ever see something like this, then I can assume that there's like a reverse going on as well. So if I'm able to call if I'm able to call from on if I'm able to call from and pass in a string slice to return a string, then I should be able to call um, into on a string slice to return to sorry yeah, to return a string. Does that make sense? Did I say that right? Because okay, there's from st okay, there's okay, hold on, there's a from implementation. There's also a method from str. I wonder if that directly calls this. Hold on. We have there's methods from dref. I haven't looked too much into dref. I should look into that. EFGH. Oh, these are associated functions. I'm supposed to look at associated functions from str. Wait, why is from str not showing up here? That's odd. Why is from str? Oh, well, there's there's a from str trait. There's a from str trait implementation. That is somewhere here. Hold on. From str. So we're gonna open this up, and here we should have from str. There it is. What did I just do? Right. I don't know what words. Oh my God. I don't know what I just clicked. Anyways, from str, this parses a string s to return a value of this type. From str, so and so. I'm going through this to see if this return if this implicitly calls um if this implicitly calls the from. What was I looking for? From or into? Hold on, let me see here. Uh let e equals string from. In from, we are able to pass in t. So there's a bunch of different implementations for from, and depending on which, wait, in this list, okay, so there's a bunch of implementations for from, meaning I can pass in a bunch of different values, also meaning that I also meaning that there would be a reverse implementation there. So in from, I can pass in a string slice, and that works. That should give us um, yeah, that should give us a string. What I forgot. Sorry, I forgot what I was trying to do. Anyways, so where was I going with this? I was talking about from and how I now finally understand what this statement is in the from trait. This is really important for me because next I want to explore the iter trait and from iter trait. because there's a lot of interesting stuff going on there. Let's uh let's do something like I don't know, let's do a vec, I guess. 1 2 3, simple vec. Okay, to iterate over this, we would need to get the iterator for it, and then we can like run a for loop or something like that. However, there is what just happened. Oh, there is an oh God, what is going on? Hold on, my whole system is like slowing down for some reason. Okay. Uh, what was I looking for? Iter. So there's iter and into iter. These are two things that I was looking into previously, and that took me down an interesting rabbit hole because um, we have iterator and into iterator. And in into iterator, I discovered the idea of blanket implementations. That is where I first learned the term blanket implementations. And I found out that in certain types there are blanket implementations, and if you look at the docs, then you'll see blanket implementations for things. Let me open up a new thing here and look for into iter. Oh, actually, hold on. There's into iter and into iterator as well, I think. There's array dot into iter. There's a bunch of different into iters. I guess because we are looking at vec, so I guess let's do this is a different kind of vec. This is the vec I'm looking for. Okay, so there's into iter, which is a struct, and there's into iter, which I believe is a trait. Yes, into iter. Actually, wait, no, this returns something. This is a struct. This is not a trait. Into iterator is the trait. Okay, conversion into an iterator. By implementing into iterator for a type, you define how it will be converted to an iterator. This is common for types which describe a collection of some kind. One benefit for implementing into iterator is that your type will work with Rust's for loop syntax. And then there was also from iterator. Let's look at implementers. I don't think any of these are. Oh, wait, these are like a lot of these are blanket implementations, aren't they? I think so. I think so. Yeah, okay. Here we have this and this into iterator for vec so and so and so and so and so. Um, yeah, no, I'll have to explore this later on. For now, let's get back to this. So the next thing that I discovered here is this thing. From is reflexive, which means that from T for T is implemented. And I found this part interesting. It took me It took me some time to wrap my head around this concept. And what Gemini presented it as, I still haven't like gone too deep into, how this works, but the basic idea is that you can convert a type from itself to itself, and that's basically just like it's a guardrail essentially, to make it so you don't lock yourself out in case you're passing in um, a similar type which already implements a certain trait. So, as an example, if you're expecting, if the generic type is, it has a trait bound of into string, then you should be able to, wait, hold on, let me trace this back. Actually, let me open up that example. Why am I trying to remember this? Let me just open up the example. So what example Gemini gave is here. I'm gonna paste the thing into, um, I'll paste the thing here. This is the implementation. This is a generic method. This is a generic function that takes in a generic parameter t, but there's a trait bound where t has to implement into string. And what this leads to is us being able to do both of these things. So what this is supposed to do is it's supposed to be able to take it's supposed to be able to take just a string slice, but it's also going to be able to take a string object if you're passing the string object. So this the reflexive thing here, the words, holy shit, the reflexivity. I think I'm getting tripped up trying to say that word. I don't use that word very often. The reflexivity here is just the fact that you are able to, because of this guardrail in place, you are able to additionally also pass in a string, and that's then going to return, well, not going to return, but like in here, uh, into would still work because it takes its own type. Though it does mention that it does nothing. So I wonder if I haven't explored that part yet. Because yeah, Gemini did mention that yeah, it does nothing, right? The whole idea is that it accepts it. It doesn't, like, it allows you to call the function and pass in that type, as in pass in its own type, even though it's not going to do anything. I haven't explored the not going to do anything part all that much. But yeah, like I said, I've kind of wrapped my head around it. I haven't fully explored this thing, but what I've understood from this is that apparently this allows you to call this function, and even though the function is expecting something that implements into string, you can just directly pass, you can directly pass a string into it. Though where is that implementation exactly? Because I did, after hearing Gemini's explanation about this, I asked Gemini, so basically string implements into string. Then Gemini replied, yes, exactly. Because of that reflexive rule, string absolutely implements into string. In fact, because it's a universal blanket implementation, every single type of Rust implements into for itself. We could see how true this is. Hold on. We are on I32. Where did I put string? This is iterator. This is from. This is okay. I guess string is lost. I think I put it on. I think I started searching on the same page, on the string page itself, and then I opened up the new link on the same page instead of opening up a new tab and doing the thing there. Let's look at the into implementations that it has. Trade implementations. Now, I don't see an into implementation. However, I do see a from string. I see a bunch of from string implementations. Oh, it's for, okay, okay. I'm looking for a simple from string for string. Hold on. No, no. Yeah, no, I'm gonna have to explore this reflexivity thing a little more. Because so far, yeah, I've understood that it is, it's more or less a guardrail, which makes it so you have, wait, let's trace this back, okay? Print loudly is supposed to take in a generic parameter, and the parameter has a trait bound of into type string. In what situation would we have into type string? There would be into type string implemented for string slice, wouldn't it? I think so, because that is how we would have from string slice implemented. Because we have this implementation, so the opposite of this is gonna be implemented as well. And because that is implemented on string slice, that is why we're able to pass in the string slice. Okay, that part is fixed. Let me, okay, you know what? Instead of doing a whole bunch of guessing here, wait, if you want to see the literal code the standard library uses to make this happen behind the scenes, it just looks like this. Impl so and so for t. Okay, I feel like I need to revisit that whole explanation again, because here's the thing. I understand that since there is no, I understand that from str for string implies into string for str. And if we look at the generic print underscore loudly, yeah, print loudly function, the trait bound is into string, which would be true for an ampersand str. How does, wait, what I don't fully understand is how there is also an implementation of into into string for string. Is it just something that the compiler assumes internally, or um, actually, I don't think it's that. Oh, or has this code actually been written somewhere in the standard library? Is this, oh, and is this common for all types? Okay, to answer your question directly, no, the compiler uh, doesn't just assume it or guess it internally. This is actual real code written explicitly in the Rust standard library, and yes, it applies universally to all types in the entire language. Let's look under the hood to see exactly how this works so it demystifies the magic, where the code actually lies. If you open up the actual source code for the Rust standard library, specifically in the core convert module, is there any way I can access that module? Hold on. It's probably going to be massive, but let's see. Is there a way I can, okay, let's type use core convert and wait. Okay, so there's the module. Will it let me go to, oh, okay, it does. How big is this file? Oh God, it's okay, that's crazy. Exactly 999 lines. That is insane. But okay, here let's where's LSP? Oh, there's no, I can't see the symbols. And Arial, I need to fix an error in it. But okay, that's fine. What am I looking for? Let's just look up into. Okay, as a library author, you should always prefer implementing from T and from, or try from T and try from, rather than into you into, or try into and try into. As from and try from provide greater flexibility and offer equivalent. So that's the blanket implementation. Yeah, it offers, wait, provide greater flexibility and offer equivalent into or try into implementations for free thanks to a blanket implementation in the standard library when targeting a version prior to. Okay, great, good to know. Good to know. Implement the into trait for consuming value to value conversions to types. Okay, but should be implemented when the conversion can fail. All right. Okay. I need to find a way to jump to. Okay. Generic implementation. Yep. This implies that. Into is. Wait, is this talking about into? Wrapper from into. Wait, this is something about a wrapper. Hold on. Does it does it look like this? Let me just paste this entire thing. Uh no, it's not here. It is not here. Yeah, it's not here. I'm gonna have to find out where it is. But yeah, okay. Continuing what Gemini said. This is the exact blanket implementation. Let me just paste the blanket implementation that Gemini has given me. Um, it's this. This is the blanket implementation, and as you can see, it implements into T for T. So it's implementing, that type for that. It's implementing into that type for that exact same type, and then that's just returning. It's returning itself. That's a hold on, wait. This function is not doing anything but returning itself. It's a pass-through function basically. Okay, all right. This is the exact blanket implementation you learned to spot earlier. Let's translate this code back into English. So impl t for any type t in existence, into t for t, implement the trait into t for that same type t. Then we have the function. When someone calls dot into, just take the item and return it immediately without changing anything. How the compiler applies it to string. Because that string exists in the standard library, because that code exists in the standard library, the compiler doesn't have to guess. It just uses substitution. When you pass a string into your print loudly function, the compiler sees the trait bound into string. It asks itself, does string implement into string? It checks its big master list of implementations, finds the universal blanket implementation, finds the universal blanket rule, and substitutes so and so. Okay, the compiler effectively generates uh, this mentally because of the blanket rule. Okay, is this common for, wait, the compiler says the rule matches perfectly, string satisfies the bound. Is this rule common for all types? Sorry, zoned out. Is this rule common for all types? Yes, absolutely, because that um, impulse so and so block uses a completely unbound uses a completely unbounded T. It automatically blankets every single type that has ever been written or will ever be written in Rust. Okay. And I32 implements into some. So okay, I'm having trouble now. Okay, I get it. I understand what's going on here now. Um, okay, if you create a custom struct, it automatically implements so and so. Okay, hold on. The takeaway: it isn't a hard-coded compiler shortcut or compiler favoritism for string. It's just a beautifully elegant use of Rust's own generic system. The standard library authors wrote a single 4-line generic implementation. And oh, something I could have done is looked for the word reflexive. Reflexive. Reflect. Okay, stop there. How many? Oh God, don't do that. Oh, there's 18. Reflexivity. This is reflexivity for this. That is for that. Okay, this is what I'm trying to, yeah, see each trait for usage examples. Are all the traits, mentioned here. Let's see if string is mentioned here. Uh, an explicit conversion from so and so to so and so is done as follows. Oh, this is interesting. They've given like example. This is all documentation. That's interesting. Yeah, I'm just noticing this way of doing like comments. This is a different kind of thing. But yeah, I'm still trying to find that. Fine. We have 18. No, that's 10. Reflexive. Oh, is this it? From and thus into is reflexive. All right. Returns the argument unchanged. This is basically, yeah, this is it. This is it. Impl t, though it says here const from t for t. Okay, so I'm trying to decide if I want to dig deeper into this because now I understand that yes, this implementation exists, and because of this, we have reflexivity in all types in Rust, right? Okay, so I looked at the convert module and uh, saw the code. So I now, oh, wait, give me a second. I now know, I now understand that, sorry, zoned out. Okay. I now understand that for every type, there will be an into T implementation that basically allows converting it into it by just passing it through. Um, Now, what I'm wondering is how that one um, generic function gets applied to all types in Rust. Um, should I keep digging or just carry on? See, that's what I'm trying to decide if I should keep digging or carry on. Because I mean, I now I understand the reflexivity thing as well. So I can carry on. Okay, you have officially asked the ultimate under the hood question. Okay, all right, fine, great. To give you the short answer, you should understand the high level concept and then absolutely carry on. You have reached the perfect stopping point for this specific rabbit hole. Digging any deeper means reading the Rust compiler development guide, which is a massive detour from learning how to actually build things with the language. Before you move on, though, here's a quick high level secret of how the compiler pulls this off. One generic block applies to everything. The magic happens during compilation through a two-step process: trait resolution and monomorphization. Trait resolution: when you compile your code, the Rust compiler builds a giant catalog of every impl block available in your program and the standard library. Sorry, zoned out. Okay, when you compile your code, the Rust compiler builds a giant catalog of every impl block available in your program, and it builds a giant impl block of wait, it builds a giant catalog of every impl block available in your program and the standard library. This is normal. Think of a normal implementation like an exact address, impl so and so for so and so. Only apply this if the type is exactly so and so type. But a blanket implementation is treated like a wildcard or a catch all rule. Impl so and so. Dude, I'm so glad that I took the time to learn generics. And I also feel silly for skipping generics initially. Skipping generics caused me so many problems, dude. And I learned the fact that generics are very important in Rust. I learned that the hard way after seeing just how heavily generics are used in Rust and seeing how much problem it was causing me um, to ignore generics. Holy shit, dude. Okay, but a blanket implementation is treated like a wildcard or a catch-all rule. So and so says that if input type matches the output type, this rule applies, no exceptions. You know what's interesting though? I just realized that what I saw was self, not ampersand self. That also makes sense, right? Um, but like, hold on. If let's say we do something like, how do I how do I like recreate this example? Like, would I be able to, it has to be something that implements string, right? Implements into string. Let's write a function here. We have some func o2. Okay, let's write a new function. Some func o3. This is going to be t um uh hold on. I don't know. I can't think of a name. Uh where t is into string. And then we'll just have a thing here, uh, type implements into string. Okay, let's say, actually, I don't think I need that. Let's call sumfunc03 and we'll pass in ABC. Okay. And then call sumfunc03 again, and we'll pass in string from DEF. So both of these should work, right? Let me turn on diagnostics. Yes, both of these should work. It's not giving an error, so I think we should be good. Yeah, I think we should be good. I don't remember what this code does. What is this project? Oh, yeah, this is the entire thing. This is supposed to throw an error somewhere here. What was the panic for? Unwrap, invalid digit. There was somewhere that I was trying to do a number thing. I32. Yeah, let's say 123. We should be fine now. Yes. So it printed out type implements into so and so. So this is how we now know that yes, there is reflexivity in this, or reflexiveness. Um I still have to look into, like, vocabulary wise how my God, vocabulary wise how I'm supposed to say this. Holy shit, dude. Words. Um okay, whenever the compiler sees you call .into, it queries this catalog because the blanket implementation has no restrictions, no where clause limiting t. It matches every single type in existence by default. Monomorphization. The copy paste phase. Rust doesn't actually use generics at runtime. Generics are purely for the developer's convenience. When you compile your code, Rust does something called monomorphization. That's basically expanding the generic function. From what I remember, it's basically re-implementing all the generic stuff for concrete types. So throughout your code, anywhere that you've used a specific, for example, a specific generic function, and you are using a certain type, Rust will expand. It'll generate the concrete implementation for you. Um, it won't maintain your generic thing within, like, during compilation. But that's what's great uh, about both generics and monomorphization and Rust, is that it gives you this convenience where you're able to define one function, and each time you call it, you can just pass in different types. Okay, when you compile your code, Rust does something called monomorphization, which is a fancy word for turning many forms into one form. I thought it was the other way around. So it's turning one form into many forms, right? Depending on how many of those types you have used. Okay, oh my God. The compiler looks at your code, sees exactly which types you used with into, and duplicates the code for those specific types. Okay, so it is doing that. If your program uses into for an I32 and a string, the compiler literally copy pastes two concrete versions into the final machine code behind the scenes. A version specifically for I32 and a version specifically for string. Any type you don't use simply gets ignored, keeping the final compiled binary small and incredibly fast. Your cheat sheet moving forward, you now completely understand how to read blanket implementations. That is true. That is true. In the documentation, you understand why they exist to give you massive flexibility and features for free. Real quick, I do want to explore blanket implementation again. Okay, because we have this. It says impl so and so so and so. Though to be fair, in from it says from, and does into also mention this? Yeah, into mentions the exact same thing. Yeah, into mentions the exact same thing. Okay, okay. Sorry, zoned out. Uh, but yeah, yeah. Now I understand that from so and so implies so and so. This is basically the idea behind our blanket implementation, isn't it? Because I feel like now I'm wondering, like, how I'm supposed to apply this to other situations where I find blanket implementations. Okay, anyways, the third thing that you understand is that they are real code written in the standard library, not compiler guesswork. Okay. Um, Real quick before we move on, is blanket implementation basically that whole from T for U implies into U for T thing? Short answer, yes, absolutely. That is a perfect real world example. But to be totally precise, blanket implementation is the name of a technique. Uh, is the name of a technique. While that from slash into, okay, yeah, I get that. I get that. It's it's the technique of blanket implementations. It's not tied specifically to from and into. It'll be done for other traits as well. While that from slash into rule is just one specific and very famous application of it. Think of blanket implementation as a tool in your Rust toolbox. It just means writing a trait implementation that automatically applies a wide range of types all at once using generics. The two blanket implementations you just learned. To drive it home, the into documentation page actually showed you two different styles of blanket implementations. One is the conditional blanket. If you implement from, you get into automatically. Okay. This is a blanket implementation because it applies to a massive open-ended group of types, specifically any type combination where a from relationship exists. The second is a universal blanket implementation. Oh, the reflexive thing. Okay. You know what? Yeah. Blanket implementation is basically when I'm able to assume that a certain trait has been implemented based on certain conditions. Wait, so would I be correct? Hold on, correct in thinking that blanket implementation is basically um, just that a certain trait has been automatically implemented based on so and so criteria. Okay, bingo. You've got it 100% right. That is the most elegant, accurate, and practical definition of a blanket implementation you could possibly have. If someone asks you what a blanket implementation is, you can confidently tell them it is when a trait is automatically implemented for a group of types based on a specific set of criteria or bounds. Okay, all right. Okay, now going back to the vocabulary for a sec, let's say I have impl from I32. Is is that syntax valid? Where's my struct? Yes, I have it. Let me just copy it. Well, I can type it. For my struct. Um, yeah. Let's say I have so and so. Um, how should I be saying this? Um, from I32. Wait. From I32 has been. No. Wait. There is an implementation of from I32 for my struct. Yes, you are completely on the right track. What you said is 100% understandable and grammatically fine. If you want to sound exactly like a seasoned Rust dev, oh, okay, sure. There are two main ways people say this, depending on actually, yeah, I would like that. Depending on because not for the sake of sounding like a seasoned Rust dev, but because I want to use vocabulary that is more accurate rather than vocabulary that makes more sense to me. Because if I'm using something that's more accurate and I'm talking to other people, then they will understand that, oh yeah, this is what they're talking about. This is what so and so so and so. So yeah, okay. There are two main ways of focusing on the struct or oh, there are two main ways people say this depending on whether they are focusing on the struct or the trait. Option one, focus on the struct. So you say my struct implements from of I32. Okay. Or my struct implements from I32, pronounced from I32. Okay. This is the most natural, everyday way of saying it. You are treating my struct as the subject during the action. Example, yeah, you can just pass that integer directly because my struct implements from I32. All right. Then the second one is focusing on the trait. From I32 is implemented for my struct. This is the phrasing used when what? This is the phrasing used when you are focused on the capability itself. It mirrors the exact structure of the code line. So from I32 comes first, and my struct comes after for. Example, we don't need a custom constructor here because from I32 is already implemented for my struct. When when to use your phrase, there's an implementation of from I32 for my struct is perfect when you're pointing at a specific block of code or a file. Example, if you look at models.rs, there's an implementation of from I32 for my struct. You know what? That's good enough for me. I'm satisfied with that. Um, yeah, yeah. Okay, cool. what was next? There was okay after this. So now, now that I understand this, this was a hell of a detour, dude. Like I was doing, I forgot what the thing is called. Inquire. I was learning about Inquire. I'm pretty confident with what I've learned about Inquire now. Um, yeah, hold on. How did we like we went back to blanket implementations, right? Blanket implementations for a certain trait. Blanket implementations for a certain trait. Hold on. Do I still have string validator? Yes. Yes, I do. String validator, acquire implementers. Implementers is here. Implementations is clone. Is there any more information here? I don't think this mentions, though I'm glad that this mentioned this thing that, you're supposed to. So it says you're a validator that receives a string slice as input, such as text and password. If the input provided by the user is valid, your validator should return OK, validation valid. If the input is not valid, your validator should return OK, validation invalid. So the interesting thing here is that in both cases it's returning OK. I don't know in what case it's supposed to return error. I'm not sure like what the idea is there. If we never return error at all, or maybe no, maybe that has something to do with like how the data is handled down the line. Yeah, maybe it has something to do with that. Then we came down here, trait implementations. Blanket implementation is not here. It's interesting that they call this implementers. So does that mean that in this we have an implementation? So in, let's say, exact length validator, I didn't know that was a thing. It's a built-in validator. I did not know there were built-in. It did not occur to me to check for built-in validators. Check whether the answer length is equal to the specified so and so. I could just use this, dude. Holy shit, I could just use this instead of writing like a whole custom validator. I mean, it depends on what I'm trying to do, but yeah, I could just use this. Uh, so this says under implementations, trait implementations, string validator. Okay, right. So, oh, what is this? Auto trait implementations, then blanket implementations. Oh, I like that this is mentioned. Wait, no, this is any. Never mind. I was connecting it to something else. Though, wait, no, it's the same thing. Impl T for no, it's not the same thing. No, 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 it's not the same thing. This is probably uh you know what? Never mind. Okay, so here we have this, and this says that what does this say exactly? Because we look at this, right? Strings blanket implementation, and if we look at um where's string here, if we look, is this string? This is string. Was I looking at string? No, I was looking at into, not string. So in into, we have this blanket implementation, right? So this is saying that for any type that matches this, we have an into implementation, right? And then here, where's this? I have too many of these. Here it says for any, in this case, function that matches this, we have a blanket implementation of string validator. Meaning I would probably be able to call, actually, okay, if there's a blanket implementation of string validator, what does that validate function actually look like? Because I'm not doing, yeah, what does that blanket implementation look like? String validator, validate, uh, yeah, dude, hold on, that's a good question. What does that implementation look like? Because, like, oh, dude, I just remembered. Hold on. Yeah, okay. I unfortunately need to end the stream. I have some stuff to do. I just remembered the time, dude. And unfortunately today as well, I started the stream late. That's completely on me. Um, I could have gone for a little longer, if I'm being honest, but I honestly could have started the stream earlier as well, and I did not. That's on me. Um, I'll try to start the stream earlier tomorrow. And today I'll make as much progress exploring this whole thing as I can. Let's see. Let's see what we are up to tomorrow because I wanna explore this thing. Like where do we go from here? Because like we would be saying that any type that has this apparently has a validator or validate implementation. But what does that implementation look like? What is that implementation doing exactly? That is something I need to find out. And maybe that's present somewhere here. Actually, no, it's not. Uh, in the with validators or with validator function though, it might be present. I think maybe I'll have to ask Gemini about this. But that being said, that is going to be it for today's stream. I don't think I'm going to raid anyone. I do have to go and do something. So I'm just going to end the stream. So that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.